think you have to be careful when you're making your argument right now that you watch out for that rebuttal. They'll just throw the word monolith out there. And, it's not good enough.
So a couple things that I've come across kind of in practice along those lines, like, yes, if you do have to partition your events, at the front door, and many systems do, if you can have a single, totally ordered event source, that's great. Kind of the event store approach. Events, I always think of like my domain like a cell, and there's like a cell membrane at the edge, and you want to write your events as close to that, as the phosphorus transfers across the cell membrane, like that's where you want to write your event, as it right as it crosses the edge. And if you can do that at the organization level, so any observations you're making about reality or anything your customers are telling you, right at the edge, you write it down in some totally ordered way. That's nirvana, right? That's where you have a total ordering across all causally related things, or even causally independent things that don't seem like they're related.
Yeah, that's exactly right. In our event modeling swim lanes down below, we sometimes put little braces on the left to say these 3 services are actually just sitting on one instance of like event store or the file system or whatever, and we don't care that that's what it is, because look how many customers we have. This thing can handle it. Don't even worry about it. The streams are divided, they're organized. If we need to migrate to something else, that's not an issue, especially if you're doing short-lived streams where you have a closing of the books at the end of the month. Those migrations are trivial. You can move that off if it becomes painful to scale up or add more nodes to that cluster, or whatever your problem is. And you need to truly start to look at get it, because the price is big. People make it like, oh, we can do this because we have enterprise patterns on our bookshelves. That is actually a huge cost. Getting rid of global ordering is a huge detriment. And so you should keep global ordering as much as possible. At the same time, you should keep your domains clean. The two are not exclusive. And I think that's the problem with the industry, is that they're painting the picture that they're exclusive. And there's vendors that would love for that to be true because they can sell a lot of stuff. And it's not. As long as you're doing proper event modeling and understanding where your data is, or whatever other disciplines you want to do, but as long as you understand where your data lives, how it travels across, where it's interpreted from one language to another, cool. But don't say that those two things you can't have with global ordering on one deployment platform, right? You can have, well, there is distributed file systems probably, but in the case of event store, you just keep adding nodes or just keep making larger instances. And that's fine. Even with Linux volume manager, you can keep adding disks, until the cows come home. It'll all be global ordered in terms of the inodes and all that. So not an issue there. Yeah, that's
but global ordering is not a quote-to-quote standard library, right? So
right. It's not a vendor that you can buy.
You don't have global ordering because it would not be inside the quote-to-quote standard library. It's the file system, and we have distributed subsystems with distributed whatever. So I don't know. I just have a bad feeling. It's okay, you make it simple, but once you need to scale or you need to change your architecture or technical things.
You do, but I believe that the complexity that you're introducing for all this eventual consistency that you have to talk about when replaying something is going to be at a slightly different order when you're replaying them back. If that's going to be a major issue, you should probably look at it from the modeling perspective first to make sure that it isn't, and that the way you're talking about data is resilient to it. So like if you got something before you expected another thing, you have a pending state on that row that you just didn't receive that. And you know what? Make the clients of that table respect the fact that this is still not ready. And it's simple decisions like that, but at least with things like event modeling, you can draw out that situation. It's like, look, here we have 5 different, departments where we can't have global ordering. And so we need to think of our information as being like this. Our SLA may be 5 minutes or maybe 5 seconds, whatever it is, but we communicate that. That's a concern that the organization has to have together. Everyone is constrained by it. And so they have to have it in their model. And you have to weigh the price of some, armchair architect that wants to implement one specific enterprise pattern, but it just doesn't fit the fact that we don't have global ordering across this. Yeah. And the fact that we don't have global ordering, well, we put an SLA around what is within the tolerance level, and therefore within 5 minutes we can expect some pendings to be here. And the odd customer might have a little spinning disk for a little bit longer. Maybe they're doing a query that most people don't do, and it's reaching back 2 months. And that's okay. Right. They might complain, they might, call, but we'll just give them a Starbucks card for $20 and explain to them that they're searching for old stuff. Yeah. That's the reality of business. You can't cover all cases, or your system would be infinitely expensive.
Yeah, sure. Just like to make clear that, hey, this is quote unquote an Oracle database feature that we're using here, and this is making it simple.
Yeah, so I agree, and global ordering is definitely what you want. There are cases where you can't have it. So, to Adam's point, if you have different departments, if you have different owners of data who get tribal and territorial within your enterprise, and I want to own my own.
Can go faster than light.
Yeah, that's right. There are ways of achieving consistent order, even when you have partitioned data. So I use Kafka. That's sort of my primary event store of choice. That's heretical in parts of the event sourcing world, and I understand that.
That's debatable.
Yeah, that's right. But what you get with Kafka is a partitioning system where you have a partitioning key, and you got to choose that key really carefully, right? So for a particular bounded context, for a particular lane of events, you're basically declaring up front, the things that go on this topic are causally related, and so they have to be totally ordered. So there's a couple options in the Kafka world for doing that. You have a single partition topic. So events in Kafka are totally ordered per topic partition. So within a partition, you have a totally ordered log. But if you have 16 partitions across that topic, you obviously don't get a global order across the whole topic. So you can partition that data smartly and say, hey, we need one partitioning key that represents the causal domain of this topic. So if the topic is about customers and customer lifecycle and registration and authentication, et cetera, customer ID is probably a good partitioning key, because then all events for a particular customer are guaranteed to be totally ordered. And a lot of times that's good enough. Having that kind of partial ordering across some sort of partitioning key, a lot of times will be good enough.
And if you screw up your partition key, you're not lost if you start to adopt closing of the books, because then you roll those, right? You can just say, I'm retiring these old topics, and cool, we just don't use them anymore. As soon as the last reference is gone, you can pretty much scrub that, right? I don't know Kafka features, but can you scrub something that you no longer use?
Yes. Yep. Absolutely.
Yeah, so there you go. I mean, same thing with event store. If you're no longer using streams, you can free up. You can free all that up. So while keeping that global order key going. So all of these things have that. And I think event sourcing has a bad name because Greg always says, I always want to replay everything from the beginning. And that's just not realistic for blue-green deploys and all that. So the idea that hydrating some sort of redoing a read model of some sort is always going to be very expensive. That's not a good thing, right? You can, it's in certain cases might be worthwhile to do it. You might have to do it if there was a problem in translating something from one stream to the next when you're closing the books. But you have a record of account for everything that's happened. Yeah. And when you retire streams, that doesn't necessarily mean you delete them. You can retire them to have an old backup or just cold storage or whatever, right? Yeah. So there's solutions for all of these things. And when your online data shouldn't be huge, so you can do all these fast movements, yet you don't want to get rid of the whole breadcrumb trail of how you got there, even from the first day that you started writing and using the system.
And Kafka is introducing features right now. They just announced it at the summit called tiered storage, where some amount of data is hot and is actually living on the disks of your cluster. And it's those data that are really fast to read. Everything else is backed up to a second tier, which may be something super cheap like S3 or some cloud disk someplace, for exactly that reason. So the 99% use case where consumers are coming online and they're starting at the end of the log, they can just go. or if they need to catch up on a couple days worth of events, great. If they need to reach back further, they just go back to S3 and play things from S3, which is much cheaper, etc. So yeah, there are ways of doing that, but you end up in a state where you are partially ordered, right? So you've got partial ordering between different bounded contexts or different domains. And maybe
it's a much better way to look at things from these types of products, whether it's Kafka or anything else, that you're actually designing that data storage to be stream-like, because we did have these features bolted onto RDBMS and they're a lot messier. Like if you can think of all the foreign keys that could kind of zigzag their way to the beginning of the first row you put into the system, you have to basically say, I know that at this boundary, I'm actually lost. SQL statements will fail, foreign keys will not be adhered to, and where do you draw that line? It's incredibly gray area that, especially if you're chasing bugs in large systems, where someone decided to give you a backup from production is going to determine whether you can actually solve your problem or not. So you have to do a whole bunch of other investigations, even just to know that you need to ask for a certain amount of data from an RDBMS system, which is, again, very hit and miss with non-trivial issues. So the point I'm making here is that technologies like Kafka, Event Store, which together actually are beautiful. I think it's one of the least, well, I think there's one really good example of it with jet.com, but I want to see there's more and more people doing the combination, which is the best of both worlds, where you can have features from both. But like Bobby said, those features are getting bolted on to those platforms themselves. So even if you choose one or the other, you still have quite a lot to lean on in those ways. And the main point I'm trying to make is that those delineations as to where you start cold storage and where you're on active, they're explicit. Like there is no like, I don't know which foreign key got dragged into this or not. You know exactly what you're dealing with. So that's a much better way to work with production systems than with, ad hoc cutoffs for RDBMS.
Yep.
Which will be pretty bad.
So to address Darren's concern that you originally raised around, it's easy to aggregate for a particular aggregate, right? We've drawn our domains. We say, okay, we're going to use this partitioning key for this bounded context. When you're building aggregates just out of that bounded context, it's super easy, right? You just do some stream processing, build everything, it's easy. The great insight from event modeling that makes cross-domain entities easier is the idea of importing an event from some foreign topic. So in Kafka world, I think of like, there's the source topics, the source of truth, canonical topics that are, my accounting department writes down and my marketing department writes down, and everyone's got their own little source of truth that is their Kafka topic that represents their totally ordered causal domain. If I want to aggregate across them, it's incumbent on me as the consumer to import those events onto my own totally ordered place, right? So as those events go by on those different topics, I don't just aggregate them and build a state out of the events that I don't control. I actually rewrite them onto my totally ordered local topic, right? It's a derived topic, basically, a derived bounded context. And this concept Adam clearly articulates in the external state import pattern, that third pattern where you see events go by, you translate those events up into my own domain. And sometimes that translation is just a one-to-one copy, right? No translation needed. I'm just importing that event into my own story, my own bounded context, because that event is important to my story. I didn't originate that event. I'm not responsible for observing that event about reality in the first place, but it's integral to the story that I am trying to record and tell. So I import those events onto my own topic, and then I aggregate my own topic. Does that make sense? So it's one extra hop, but then when you aggregate your own topic and the schema changes, or you need to replay or something, you just replay your own topic because now you have a total ordering over those events.
That's what for me is the only thing that makes sense, because if you're honest, you're relying on a technical thing and the reality might differ. So an event not necessarily has happened in that very moment that some subsystem receives it, right? If I mean the fallacies of distributed systems, and we know that, right? The network might be down, Like the reality is some decision maker clicks a button, but the network is down, or go through a tunnel, has no. So yeah, the decision was made, but it didn't reach through, right?
I didn't become aware of that decision. I didn't become aware of that event until
exactly. This is one example, or just the network was down of this one whatever cluster, or so anything can happen, and so you receive the event after the fact. But you need to do, as a, like I said, this subsystem consumer, you need to do your own deduping and resequencing. And this is business logic. In the end, it's a business decision.
Yep.
And you should be aware of it and at least make a conscious decision about if everything fails. And I mean, everything fails all the time. This famous quote. So what are we going to do in this case?
Yeah. And
do we care or don't we care? Should we address this? Is it worth to address this? Or just make a conscious decision. But even if you use quote unquote Oracle database features, and for me it sounds too much like the ESB anti-pattern. You rely on the dumb pipes are not dumb anymore, and this always gives me a bad feeling. I know it makes things easier maybe to start out with, but if you've been there,
I don't think it makes anything easier. I think it gives people a satisfaction that they're learning another tool, and that they have the perception of something being done for them. But every single moment I've seen it,
get event store or whatever, instead of relying on dumb pipes only, and do the deduping and resequencing inside their own context, like Bobby, like you said.
Yeah.
This is how I would default to, or at least make it very clear what are the implications if you use this. Yeah, earlier you would have said enterprise service bus. Today you say Kafka or Get Event Store or whatever. Just know what you're dealing with and how it scales if you need to scale, and so on.
And that insight, Andreas, that insight that I just enumerated, that Adam, explicitly includes as that third pattern in event modeling, where I'm translating events that are foreign to me from some other bounded context, and I'm translating them into my local contexts. Making that explicit and actually explicitly writing those events down, the business semantics of that are really clear. Our bounded context became aware of this event at this causal time, in this causal order. And writing that down and remembering in what order I became aware of these events has some meaning, right? That has semantic meaning, because things do happen, technical things and business things happen, such that when some other group becomes aware of a decision is going to be a different time than when I became aware of a decision. But the order in which I became aware of an event impacts the work that I'm doing locally. And so we have to treat everything else as foreign and outside of our domain. So drawing those boundaries clearly and recording my own causal history, which may include subsets of other people's causal history, writing that down as my own order is super, super important. And it's one of my favorite subtle things about Adam's event modeling is that idea of external state import via events, make that.
Yeah, it's based on systems thinking, right? Understand what your scope is, what your world is.
What can I control?
Therefore you can do your job. The worst thing that I hated, this comes all from experience of suffering, right? We did all this because a lot of times, how many times have you been in a project where you were not in charge of your own destiny because of a dependency on another team, right? You need to be able to tell your management that you have finished with this system, and these clear contracts between these systems is how Amazon scaled. This is what Bezos forced on everyone in Amazon to be able to resell all the 160 services that they have now, right? And make them available to the public. That's what it is. It's about saying that I finished system A. System B is not finished yet for whatever reason. It might be that people are lazy, maybe they miscalculated how long it's going to take, but it doesn't matter. Their failure shouldn't affect me, right? And so the minute that you start to chain things together, you start to make, quote unquote, a chain where the weakest link is going to break the whole thing. And so now what I have, at least when I have the systems thinking, and I know that if I go to that other bounded context down below in the other swim lane, I can have maybe the senior people go in and help out that team. All of a sudden, they can reset their minds and think from that perspective, but the contracts spell out how the Lego pieces click together.
Yep.
And I think how the Lego pieces click together was never clear enough because we never elaborated that kind of dependency over a timeline to give situational awareness of how they interact. So they were always written in some weird use cases, and they got even more high level when it came to cross system use cases. You know, you really couldn't give that use case to one team because it involved multiple teams. So I guess this is why we have event modeling, is because we need that canvas for talking about that type of use case.
Yeah, it's a business decision, I would say. It has to be a business decision. And there are two orderings, Bobby, what you said. There's the publisher ordering, and there are N subscriber orderings.
Yep.
So, like this resequencing, of course, Adam, like you said, some process has to wait. If you receive number 1 and then event number 3, I mean, of course, you received, you missed an event. So you wait. How long do you wait? It's a business decision.
Mm-hmm.
Should you wait? If yes, how long? That has to be a business decision. It should be part of the
justifiable. It's an explicitly justifiable business decision too. If you write down your own local ordering, you can have the traceability and go back and say, you know, if someone comes and says, hey, why didn't you do the right thing in this situation? You can say, hey, we didn't become aware of fact B until well after fact A, and I can show you in my ordering. I can show you.
Exactly. Yeah, you have the two orderings, the publisher ordering, and then when you received it, and based on those two orderings, then you can make a business decision and audit and proof. Yeah. Yeah,
exactly, Andreas. And then you can do the 5 whys analysis for, well, why didn't this particular subscriber who's doing this important sub job, why didn't they know about this? You know, we recorded the original canonical event at the edge at time, you know, wall clock time 100, and you didn't become aware of it until wall clock time, you know, 130. Why? Was there a system outage? You know, now we can start to sort of address the business level concerns of, you know, why are we not communicating internally the way that we ought to be? But then, you know, you're not talking about Lamport clocks and you know, partial ordering and window joins and stuff, right? You're not having a nerd conversation. You're having a business conversation about.
So back to business. This is a good point that Andreas brought up. This is a business decision, and this is how you punish business for shirking responsibility and throwing things over the wall to say, oh, this kind of stuff, that's developer talk. And then if things don't go well because this is subpar requirements, we'll blame developers for making the mistake. Now, I don't want to be the developer always, you know, boss bashing. The converse is also true. Like the other way around is also true, where developers use that same argument that, hey, this is technical. You don't get to make that decision.
Yeah.
Right. So it punishes the bad actors from both sides. You need the canvas to understand exactly what's going on. What are the SLAs and why are they like that? And what are your compensating actions, and is everyone okay with that?
Yeah, Adam, I'm pretty sure you have a lot of examples from, let's say, the pen and paper world or from traditional systems, how it was done there. So also in this case, I think it's good to go back and think, how was trading back then without computers or the in-house?
I simply don't have enough experience with the trading world from that era.
But with those air pipes, right, where you put a paper roll in this cylinder and you send it to the in-house mailing system, and something got stuck or something, right? So you have this publisher time, like a sender ordering, but the receiver might not receive it in that very moment, or not in the usual couple of seconds delay, but maybe an hour later or something. And also there, it's a business decision. And I guess back then it was even more clear because business people maybe better understood the physics of just this transportation system. Oh yeah, something can get stuck. Okay, what are we going to do about it?
You're right. I think people were more understanding of each other's rules before, because the tooling has become, with digitization, it became that geek world was born, right?
Well, and there's also the illusion of real time, right? Like this whole idea of a system, you know, it's sort of the current vogue of microservices where everything's synchronous all the time. Everything knows everything it needs to know all the time, and instantaneously knowledge is transferred among all these things. That would not scale, for example, to a relativistic system where some participants of the system are on a spaceship, some are back on a planet, some are near a high mass object. Event modeling would totally scale to that relativistic world where time is an illusion.
Everything. That's I say everything always is eventual consistency.
Yes.
Sometimes
I like to show eventual
much
consistency in an event model, right? I like to show event.
It's explicit in the event model. Yeah.
Yeah, it's really easy to show how something got written, but one of the diagonal arrows going to that screen happens later in time. So you can show that this old screen is still what's being, what's seen here, or what's stored, or what's in this read model, or what's wherever. But whatever vertical timeline you slice up, you can show that there's your 2 seconds problem. What do you want to show the user? I'll just put a spinning disk there, that's fine, right? Yeah. Or this has to bubble up, but that has to come from business.
Up to this amount of time, I can tolerate stale data for this amount of time.
Yeah, or the user can tolerate a spinning circle for waiting for up to 2 seconds. If it's more than 2 seconds, we go, something went wrong, please contact or whatever, or we'll email you and we'll resolve it, but it's a business decision. It's not for me as a technician, a technical person, a programmer, to guess what the user wants. The organization together has to understand what the vision is for what this organization is doing for its users. And so these things, this is shirking responsibility, from many people. And I think it's about, I think a lot of people hide behind the guys that need to be an expert at something. And it's a way to make yourself look good while starving another team from information so that they look bad and you get the promotion. So there's a lot of political things that are activated by not communicating correctly. And that's horrible, because that allows subjectivity and a whole lot of things. And there's many reasons why I love event modeling from the human side, because it gets rid of guesswork, subjectivity, discrimination. A slice is a slice, costs the same. If whatever your gender is, whatever your skin color is, it doesn't matter. Everyone gets paid the same for each slice. And even if you have a different tech stack, we're not even biased to a specific technology at this point, which is great. And we want to keep going in that direction. Have companies that are fully digital be the best places to work, because they're mature. They have a mature way of looking at what they're automating. And I think it's really, really good.
So one last technique that I will mention in this connection, because it's super, super important, and I don't think it gets enough play. Before I came to the event sourcing world, I worked on a database called Datomic. And again, because that's kind of my thing today, invented by Rich Hickey. Datomic is this database that has this sort of built-in notion of time. It turns out that the whole architecture of Datomic is built on immutable data, CQRS, and event sourcing. And I didn't know any of these. I knew immutable data, but I didn't know CQRS or event sourcing when I was working on this database back in 2014, 2015 kind of timeframe. I guess 2012 to 2013 timeframe. But that's what it was. And the whole idea of Datomic is you treat the database like an immutable data structure, like a persistent data structure in memory, where I have this data structure and it never changes out from underneath me. The value that I have is truly a value, and I can query it and interrogate it like a value, and nobody else can change it because it's not an object or a reference pointer. It's just a value in memory. So Rich Hickey built this database that had this characteristic. And part of the idea of that is that each transaction that's added to this database represents a logical clock in time of changes to this data. So if I get the database value, so I have a connection to the database, but that's a separate object. The connection doesn't tell me anything about the data that's in the database. I grab a database value off that connection, and now the thing that I have in my hand in memory is consistent and will never change, and it represents the database as of a point in time. So it represents the database at time t. And I have this data, transaction t+1 and t+2 and t+3 can arrive while I'm doing some long-running analytical query on the database that I have at time t, but I don't care and I never see that. I just have this consistent database view. So that allows sort of the reintegration of OLTP and OLAP concerns in this data store, because I can do some long-running analytical query and it's guaranteed to be consistent the whole time I'm doing this query that takes 20 minutes, because I'm querying the database as of a point in time. This also allows me in Datomic to time travel and say, hey, show me the database as of, t minus 100, which was last Tuesday. Show me what the database looked like then, and I can query the database, as of that point in time. I can even do kind of what if extrapolation or hypotheticals Or say, what if I had this database as of time t and I added these 5 transactions? Let me query the database then, see what it would look like in that case. Anyway, the point I'm making is there was this really strong notion of time built into Datomic as a data store. Other databases have followed suit. There's one called Crux now. There's a handful of others that have this really strong notion of time where I can query the database as of a point in time.
Yeah, another famous one is Git.